Hi everyone. Today I have brought a very good question from the topic of Gauss Law, and it is actually asked by one of my student, and it's a good level question. But before we start solving the question, I would like to first say something about how to find area of one part of a sphere. So imagine this is a spherical surface, okay? Spherical surface, three-dimensional, whose radius is r. Then we all know the surface area, the total surface area of a sphere is 4 pi r square, isn't it? All of us know this. Now, if I take a small part of this surface, okay, let me remove this. So if I take a small part, okay, so this is the front part and this is back side, okay, this dotted part is the back side. So I am talking about this part, this area. This area. So it's like a cap, okay, cap. So what is the area of that surface? If I ask you, then actually the derivation involves integration, and actually I have done this long back. So I will share the video of that in the description. If you want to know how to find area of this part of the surface, you can see that video, okay. Otherwise, there is a direct formula. Let me tell you that formula, which is important for JEE students to remember. So let's say the angle made by this circle at the center, the half of this angle, this angle is, let's say, theta. Then this area, this part of the area is given by area of this cap, okay, that is given by 2 pi r square 1 minus cos theta. Now you need to memorize this, okay. What is the area of this cap? 2 pi r square, r is the radius of the sphere, and this theta is this angle, okay. Try to remember that. Now one easy way to remember this is, think of this area of the cap as the whole sphere. Then if this area of this red color cap, if this was the whole sphere, then this dotted line would come like this to cover the whole area. That means your theta will be 180 degree, right? And if theta you put 180 degree, you will get cos 180 minus 1. Minus, here minus will be plus, so 1 plus 1, 2. 2 into this will be area of the whole sphere. So this will become this when theta is 180, right? Now let me read the question. It says a charged shell means hollow sphere of radius capital R carries a total charge capital Q. Given phi as flux of electric field through a closed cylindrical surface of height h and radius small r. Capital R is the radius of the spherical shell where there is charge, okay, and here small r is radius of the cylinder where there is no charge. It is just a cylinder through which we have to find electric flux, and with its center same as that of the shell. So center of the cylinder coincides with center of the shell. Here center of the cylinder is a point on the axis of the cylinder which is equidistant from its top and bottom surfaces. Now which of the following options are correct? So this is a multiple option correct question. So more than one option can be correct. So they have given you a spherical shell. Remember, it is a spherical shell, not a circular ring, okay. It is not a ring, it is a shell, and the charge will be obviously on the surface. Total charge is capital Q, uniformly distributed, and the radius of this is capital R. Now they want electric flux of the electric field created by this charge through a cylinder, and cylinder radius they have given small r and height they have given h. and they told the center of this coincides with this. Okay, center of the cylinder coincides with center of the shell. So now in 4 options, one by one we have to check what is the electric flux through this cylinder. Now this is a closed cylinder, is a closed surface, so we can use Gauss law. But to find the flux through cylinder, we need to know how much charge is inside, because according to Gauss law, flux through this cylinder will be equal to charge inside the cylinder divided by epsilon naught. So let us check one by one how much charge will be inside the cylinder in different options. So in the first option, they have told height is greater than 2r. So this height is greater than 2r. 2r means this diameter, yes or no? This is 2r. So this height is greater than this, and this radius is greater than capital R. So this is your radius of the shell. So radius of cylinder is greater than radius of the shell. In that case, they are saying flux should be equal to Q of the sphere divided by epsilon naught. So this is correct or not, we need to check. So let's draw a diagram for this. So remember, they told center of the cylinder coincides with center of the sphere. Now let us say this is the sphere, okay, where there is charge. Now how I should keep the cylinder? Remember, the height is greater than this. So height of this cylinder is greater than this. Also the radius of this cylinder is greater than this. This is capital R, this is 2r. So my cylindrical cylinder should be something like this, isn't it? Because the height of the cylinder is greater than 2r, you can see, and the radius of the cylinder is also greater than capital R. So in that case, how much charge is inside the cylinder? Obviously the whole charge is inside, so therefore the flux will be equals to charge inside, total charge inside by epsilon naught. So first option is correct, right? The second option is saying the height is less than 8r by 5, 8r by 5, and the radius is equals to 3r by 5. Now 3r by 5 means 0.6r. So clearly r is less than capital R, isn't it? Because it is 0.6r. So radius this time is less than capital R. And height is less than this number. This number will be how much? This is 5 ones are 5, 3 carry, 5 6 are 30. So height is also less than 2r. So if this was your sphere, okay, you know that this is radius of the sphere, this is the diameter of the sphere. So this time, how you should draw the cylinder? Well, the radius of the cylinder, small r, is less than capital R. So it should be here, right? Radius. This cylinder should be like this because the radius of the cylinder is less than capital R. Also, the height is less than 2r because it is less than 1.6r. So it is less than 2r obviously. So your cylinder will be somewhat like this, isn't it? Right? So this is the radius of the cylinder which is less than capital R, and this is the height of the cylinder which is less than 2r, because this less than 1.6r means it is less than 2r also. So therefore in this case the charge is completely outside the cylinder, isn't it? Because the charge is on the shell. So since no charge is inside the cylinder, the flux through the cylinder will be 0, and that is what option B told. The option B told flux is 0 through the cylinder. So option B is also correct. Now in the third option, they told the height of the cylinder is greater than 2r and the radius of the cylinder is 4r by 5, which is 0.8 r, so which is less than r, right? The radius is less than r. In that case, flux through cylinder is given this. We need to check it's right or wrong. So let us again draw the sphere. Remember, this is the radius and this is the diameter. Now our cylinder height is greater than 2r, so our cylinder should be somewhere here, right? Height should be here. This is the axis of the cylinder, so the height should be greater, and the center of the cylinder coincides with center of the sphere that they mentioned before only, and the radius should be less than r, so the radius should be up to here, let's say. So this is 0.5 r, 0.8 will be somewhere here. So this will be your cylinder. Correct? So this radius is small r. This radius is small r. Okay. So now if you observe carefully, how much charge is inside? This much charge is inside the cylinder. This much charge and this much charge. Now how to find charge on this much part of the sphere? For that we have to use unitary method. What is unitary method? If you know price of 10 apples, then you can find price of 6 apples, right? Price of 10 apples divided by 10 into 6 apples will give you price of 6 apples. So the charge capital Q divided by total area of the sphere, this is the total area of the sphere, into this area of the sphere, this cap, which I already discussed in the first part, because that much area is inside the cylinder if you look carefully, right? So this much area on the cap, which is a small part of the sphere, that much area is inside the red color cylinder. So to find charge on that cap, what I should do? Unitary method. Total charge by total area into area of the cap. Now to find the area of the cap, I need to know this angle I told you, right? So if I draw this triangle here separately for you for clarity, okay, this theta, then look carefully. This is the radius of the cylinder and this is radius of the sphere. So from here sine theta will be what? Opposite by hypotenuse. And what is small r they told? 4r by 5 in this question. So this is divided by r. So sine theta is 4 by 5. So what was the formula for area of the cap I told? Area of the cap, if you remember, I told is, here I mentioned, right? 2 pi r square 1 minus cos theta. Well, I know sine theta is 4 by 5. So if I draw a triangle with theta here, opposite is 4, hypotenuse is 5. So this adjacent side will be 3. So what will be cos theta? Adjacent by hypotenuse. So this will 2 pi 4 pi will cancel, r square will cancel. So q by 2 1 minus cos theta is 3 by 5. Right? So that will give me q by 2, 5 LCM, 5 minus 3, 2 cancel, q by 5. So that much charge is inside the cylinder here. But similarly this much here also is inside, isn't it? So here also one cap you can see, same. Right? So same part will be inside. If you draw it properly, I may not have drawn it symmetrically, but same amount of charge will be present here also, right? So the total charge inside, the cylinder will be 2 times charge on the cap, this cap and this cap. So that will be 2 times charge on the cap, which should be 2 times q by 5. And once you know charge inside, the flux through the cylinder will be equals to charge inside by epsilon naught. But they told q by 5 epsilon naught. Our answer is 2q by 5 epsilon naught. So this is wrong, right? Now in the last option, the height of the cylinder is again greater than 2r, but radius of the cylinder is 3 by 5 times radius of the sphere. In that case, the flux is given this much through the cylinder. We need to check this is right or wrong. So again, this is the sphere. Let's say you know that the diameter is 2r and the radius is r. Now I have to draw the cylinder in such a way that the height is greater than 2r. So the axis should be somewhere here, greater. And the radius is 3r by 5, which is 0.6r. So somewhere here, let's say. So let me draw properly this time. So this is your cylinder. Okay. So you can see this time this much charge is inside. Now this is charge not on a ring, okay, this is charge on a sphere, because this is actually a sphere. So to find charge on that, you have to first find the area of this cap, which already I told you how to find. So charge on this cap will be what? Total charge by total area into area of the cap, which is 2 pi r square 1 minus cos theta. R square 2 pi and 4 pi will cancel, will give you 2, so q by 2 1 minus. Now cos theta, well, you draw this line and this is your theta, I told already, isn't it? So if I draw this triangle here for you separately, this triangle, then this is radius of the cylinder, which is small r, and this is radius of the sphere, and this is your theta. So sin theta will be what? Small r by capital R, which is equals to 3 by 5. If sin theta is 3 by 5, cos theta will be what? 4 by 5. Okay, you can check. So now cos theta is 4 by 5. So this will be 4 by 5. This will be q by 2, 5 LCM, 5 minus 4, 1. So q by 10. So the charge on this cap is q by 10. Similarly, charge on this cap will come, which is also inside the cylinder. Right, this is also charge inside the cylinder. So the total charge inside the cylinder is 2 times the charge on the cap, which is q by 10, which is q by 5. So now if you use Gauss law, flux through the cylinder will be charged inside by epsilon naught, so q by 5 epsilon naught, which is correct. So which are the right options? First one, second one, and last one. Okay, third option is wrong.